Welcome to the story of Agent X, Code of Atlantis.
Welcome everyone. So today we are going to see the 5 problem set based upon the division rule. It helps us in various algebraic methods. So we'll go through it and we'll learn the problem solving method. So here is the story, that is Agent X and the Code of Atlantis, the patterns and the relations. So the story is, meet Agent X, a cyber detective in the year 3050. He has intercepted a signal from the lost city of Atlantis. The city is behind a quantum firewall that can only be opened by solving mathematical patterns. The firewall is protected by 5 layers of encryption. Agent X needs your help to break the code using divisibility rule, algebra, and linear equations. So let's see the data intercepted. So the firewall displays a massive number and a warning. Only those who understand the factor of the ancients may pass. Agent X pulls up his holographic interface to analyze the pattern. So let's see the mission 1. So the mission 1 is the divisibility gate. So the task, let's see the task. The task says the first layer of the firewall requires a key number that satisfies specific harmonic frequencies. The number on the screen is 14,928. To pass this number must be strictly divisible by 3, 4, and 8. If it fails any of these, the alarm triggers. So let's see the question part now. So we need to use the divisibility rules to determine if this number is divisible by 3, 4, and 8. And we need to show a specific test and do not just divide. So let's see. So let's check whether for the test for 3 gets passed or not. So if any number is divisible by 3, the sum of the digits of that number should be something which is divisible by 3. So the number which was given to us originally is 14928. We add up each of this number here and we see that its sum comes out to be 24. And the 24 is divisible by 3. That how? Let's see. So it is divisible by 3 times 6, that is equal to the 24. So we could say yes, 24 is divisible. That is, the sum of the digits of a number is divisible. Thus, this number is divisible by 3. Now, let's test for 4. The number formed by the last 2 digits must be divisible by 4. So, in this, the last 2 digits are 2 and 8, that is 28. And we know that 4 times 7 is equal to 28. So that clears that this number is divisible by 4 as well. Now, test for 8. The number formed by the last 3 digits must be divisible by 8. So, last 3 digits of the number 1, 4, 9 to 8 are 9 to 8. So, we divide 9 to 8 by 8 and we see we get 160. So, that means that this is divisible by the 8. So, as it satisfies all the 3 conditions, that is the test for 3, test for 4, test for 8, it is divisible by 8 as well. So, the number is divisible. Now, as we know, like if the number is divisible by 3, 4, and 8, the access will be granted. Thus, the result is there and we have been granted the access. Now, let's see mission 2, the energy code expressions. So, let's see the task. Agent X has breached the gate, but how he needs to power up the ancient generator. The generator consumes quantums of energy based on a variable formula found in the manual. The manual states the energy required is equal to 50 quantums for startup plus 20 quantums for every hour that is represented by H the system runs. So the question has 2 parts. Let's see each of them. So it says an algebraic expression for the total energy needed for H hours. The part B asks, if Agent X needs to run the system for 12 hours to download the data, calculate the total energy required. Let's see. So for the A question, let's understand the question. So basically we need to write an algebraic expression for the total energy needed for H number of hours. So startup is the fixed, that is one time it will be started, so that will be 50 quantums. Now, hourly cost will depend solely upon the number of hours we use. So how much 1 hour cost? So 1 hour costs 20. So that means if we run it for like h number of hours, okay, h number of hours. So what will it be? It will be equal to 20h, and the total cost will be what? The 20h, that is the hourly cost, plus the constant, that is the startup cost. So here we form an algebraic equation. Now the B part said that if agent X needs to run the system for 12 hours to download the data, calculate the total energy required. So 12 hours is the number of hours we need to calculate for. So in this, we'll just substitute the value of h as 12, as you could see, and we will be getting an answer by solving this. That is 20 times 12 is 240, that is added to 50, resulting 290. So the answer is 290. Mission 3. So the mission 3 is the laser grade relations. Let's see. The task. Agent X enters a hallway protected by shifting laser beams. He notices a pattern in the number of beams as he walks through the sectors. Sector 1, that is n is equal to 1, has 3 beams, as you could see, 1, 2 and 3. Step 2, it has 5, 1, 2, 3, 4, 5. Step 3 has 7 beams, 1, 2, 3, 4, 5, 6, 7. Now, the question asked to us is, write a linear relation. Basically, we need to create the formula that connects the sector number to the number of beams. So let's see. For this, we need to observe the pattern. So if you try to observe the pattern, you will see it increases by 2 each time. So this is 3, this is 5, then this was 5, this is 7. So as you could see, from 3 to 5, so plus 2, and from 5 to 7, it was plus 2 again. So how is it increasing? So let's see. So as you could see, the number that is increasing, it is increasing by 2, right? And for each step, if we contain n, see n is equal to 1, n is equal to 2, n is equal to 3, and so on you could go. But for this, we only have the n is equal to 2. So in this, n is equal to 1 and n is equal to 2. Now for this, it will be 2 times n, but it is just not 2 times n. It is also increasing by 1, so we'll increase it by 1. Now if you see and try to put the values of n in this, so it will result at n is equal to 1, it will result as what? It will result as 3. At n is equal to 2, it will result as 5. And if you put n is equal to 3 as well, so you will see that you will be getting 7. So this is how we form the linear relation between the sector number to the number of beams. The number of beams, as you could see, is increasing by 2 each time. This means the formula involves 2n, and then we add 1 to reach the number of beams. So we form the relation that is 2n plus 1, right? The B part says of the question that how many beams will be in sector 50. So in sector 50, so just put n is equal to 50 in our existing relation of 2n plus 1, and you could see as we put, we will get 101 beams. So it will be quite a hectic task for the agent X. Now let's see mission 4, that is the final vault. So the task is agent X reaches the final vault. A robotic voice speaks a riddle that must be translated into math to open the door. So let's see the riddle. So the riddle says, to open me, find the secret number X. If you multiply the secret number by 5, add the 15, the result is 110. You must have saw the videos on YouTube, and might as well your friends would have tricked you that they ask you to just think about one number and do certain operation like do the plus 5, then multiply it by 2 and so on, and they ask you the number in between and they ask again to repeat the process, and they magically tell the number you initially thought in your brain. So how does that actually happens? So it is all the maths. Let's see how it happens. So the question 4 says, write an equation for the robot's sentence. Let's see this. So for the robot sentence, let's see, to open we find the secret number X. Okay, let's see. If you multiply the secret number by 5, let's say the secret number is x, and if we multiply the secret number by 5, then add the 15 to it, okay, and then add the 15 to it, the result is 110. So we need to write an equation for the robot sequence. Bravo, we have written that already. That is 5x plus 15 is equal to 110. Right, so this is our equation. Then the question 5 says solve the equation to find the secret number x. So let's solve this equation. So for solving the equation, we do the simple algebraic things, that is we subtract 15 from both sides, so we get 95. Then we divide by 5 both sides, and we finally get that x is equal to 19. So the secret number decoded is 19. So we have finally accomplished the mission, and that's how we helped Agent X. I hope you all have enjoyed the journey of Agent X and have learned many things meanwhile helping Agent X. So subscribe the channel, like the video, and comment down the question which you like most, the task which you like most. We meet in the next video. Till then, bye bye. Have a nice day.